Operator initiated check escalation. An airline, through continuous data collection and analysis, may identify an opportunity to initiate a check interval escalation. Increase fleet size. Scheduling the requirements or available downtime may also initiate a review for a possible check interval escalation. The escalation and sampling program must conform to the interval and program limitations approved by the local regulatory authority. Again, we cannot go outside of the framework that's set for us by the regulator. We can see here that we've got a process that we can follow. And first question is the current interval mature? What does that mean? Well, remember before it said with a new aeroplane we have to reach a level of maturity. So we're talking about some years, a couple of years. So the answer is, if it's not mature, we stop. Come back in the future. So the answer is yes, it is mature. We've been in this environment now for a couple of years. So define the planned sampling, because the only methodology that we can use is to do a sample. We have to say we want to escalate, let's see what happens. And a typical sample size would be 10 or 20%, which is why we're looking at 10 aircraft giving us 1 or 2 aeroplanes in the sample. So again, this is typically a threshold. Could you do it with 8? Yes, you could do it with 8. You could do it with 5, in actual fact. 5, it would still give you 20%, it'd still be within the boundary. Okay. Define the planned sampling. Any dropouts? What would be a dropout? Well, some tasks, remember, airworthiness limitations, CMRs, they're not necessarily going to be escalated, so they would drop out. And the dropouts can become disposition of the dropout. They can become standalone. You can control them using an out-of-phase maintenance control process. And you see some airlines have an OPM process. And you see in the tech log there is a document and it says OPM, out-of-phase maintenance. We accomplished the check. This is the check now at the new proposed period. We look at any findings. We compare the findings with our normal expectations. We've now got a reliability input. We can take now a decision. Is the new proposed interval justified? If it's not, it's game over again. We go back to the beginning. If the answer is yes, we again ask the question, is there any dropouts based on the finding? And it could be, okay, the majority of the check is going to be okay, but there's one aspect that's not. Okay, that also drops out. And then we have approval from the regulator. So that's the methodology that you would expect to see in place. It's a controlled, step-by-step process. It's agreed in advance with the authority. You take a sample and you use your sample to test the escalation. That's exactly the process. Maintenance is one of the most significant costs within an airline operation. So the opportunity to reduce the expenditure without compromising safety is worth considering. Have a look at how much it's going to cost us to do a particular check. Here we've got a 737-800, and we can do a light C check. This is 2010 prices for between $120,000 and $160,000. A heavy C check for between $220,000 and $320,000. Have a look at a 747. A heavy C check could cost between $1 million and $1.2 million. And so on between, with different intervals, different prices. So with a fleet of aeroplanes, a 777 there, coming in at between 550 and 650,000. This is for the basic C check. This does not pay attention to any additional items that may also be involved. So the bottom line is maintenance is expensive. If we can cut the cost of this maintenance, it's very worthwhile. This is C checks. Now we're talking about heavy checks. And here we're looking at 120 months to 144 months. So we're looking at checks that take place now every several years. And we can see the cost now. For a 7.3, the cost is 1.3 million. We can see for a 7.4, we're up to $4 to $4.5 million for a maintenance check. Here we're up to 2.5 to getting on for $3 million for a 777 for the heavy check.